My name is Derrick Jack, Senior Instructor here at Tulsa Welding School, Houston campus. And today we will introduce you guys to the GTAW process, commonly known as TIG. TIG is going to be the most difficult to learn. It's going to require a higher level of skill. It's going to require extreme concentration and focus. But the first thing you want to know is what parts that make up your TIG torch and how to put those parts together. This is your TIG torch. It's a 17 series TIG torch. It's air cooled and is rated at 150 amps. Your back cap, it comes in 3 different sizes. You have a long one here, and if you wanted to add to your collection, you can get a medium or a small. Your TIG cups comes in 5 different sizes. There's your 4, your 5, 6, 7, and your 8 cup. As you can see, the larger the number, the bigger the cup. The smaller the number, the smaller the cup. Your tungsten here is 3/32 tungsten, and those tungsten is 2% seriated. There's different types of tungsten with different material added. You can get 2% thoriated. You can get 2% lanthanated if you need those. Right now, the seriated would be perfect for what you're trying to do here. You have your collet. Your collet is a 3/32. Your gas lens is a 3/32 also. Those 2 parts has to complement your 3/32 tungsten and has to be the same size as your 3/32 tungsten. Your insulator is here and your tungsten tote. Now let's go ahead and put your TIG torch together. First part you're going to start with is your insulator. You're going to take the tapered side of that insulator and place that on the face of your torch. You want to hold it, grab your gas lens, and screw your gas lens in. Be careful not to cross thread that gas lens, because if you rip your threads up on the inside, you're going to ruin your torch. Your gas lens is the only part that you really want to ratchet down and get it really, really tight. Next, you're going to choose what size cup you want. Get it, screw it on. With your cup, you're going to only screw it until it stops. You don't want to tighten down on it. You don't want to ratchet it down, because when you go to disassemble it, it's going to take off everything. Grab your collet. We're going to look at this collet as a kind of sort of a missile. The side, the smaller side, is going to go in the back of your torch here. Drop it in. Boom. Get a tungsten. Place your tungsten through. Add the back cap. Much like the gas lens, with your back cap, you're only going to screw it in until it stops. Now, a bit of information about the back cap. What that back cap does is it actually locks your tungsten in place. So if I loosen this back cap, I can slide my tungsten back and forth. But once I tighten the back cap until it stops, my tungsten won't move anymore. And that's the way you put a TIG torch together. Let's talk a little bit more about tungsten stick out. Your tungsten stick out is going to be dictated by the size cup that you're using. If you're using a number 8 cup, which is a 1/2 inch across the front orifice, your maximum stick out will be 1/2 inch. Your minimum stick out is going to be barely the minimum, barely the tip coming out of that cup. Your typical stick out is gonna be half the distance of the orifice, which is gonna be somewhere in here. Like I said earlier, your stick out is gonna be dictated by the cup that you use. If you go down to a number 7 cup, your number 7 cup is 7/16 across, 7/16 of an inch. The easy way to measure is gonna be to put your tungsten up against it here, and that is your maximum stick out, which is 7/16. It's gonna look something like this. There's no need to measure, just can eyeball, because you're gonna adjust that tungsten stick out as you go. So your maximum is gonna be 7/16, your minimum is gonna be barely the tip, and your typical, which is right in the middle, which I would start with, is gonna be half the distance of the orifice of whatever cup that you're using. Let's see what that's gonna look like with another cup. Let's go with a number 5 cup. Number 5 cup is 5/16 across. 5/16 across is here. So that stick out is gonna look something like, the maximum stick out is gonna be something like so, which is equal to distance across of the orifice. Minimum stick out is gonna be barely sticking out of that cup. And your typical is gonna be half the distance. I'm gonna measure here, take a look at it, and I'm going to just eyeball it because I'm gonna adjust it as I lay my torch on the part that I'm welding. Now that we explained how to put your TIG torch together, and we talked a little bit about tungsten stick out, we're gonna go sharpen our tungsten and show you how to attach your TIG torch to your machine so that you can make that TIG weld. Follow me. Now that we've made it to the shop, we're gonna take on the task of actually sharpening our tungsten. Sharpening tungsten does not take a great deal of skill, but you have to have a certain amount of safety awareness so that you'll do your job in a safe manner. Because the tools that we're going to use can cause injuries. Those injuries can be small or those injuries could be big. So there's certain PPE that we must use while we sharpen our tungsten. At a minimum, you want to use a face shield for double eye protection, and you're gonna use gloves for hand protection. So we're here at the bench grinders, and the first thing you'll notice is that I am in the shop, so I do have my eye protection on. Now we're gonna look at the bench grinder, and we're going to understand how to power up that bench grinder, how to get it going, and how to actually sharpen our tungsten. So first thing, you want to come into the area. We're going to see this area here with the bench grinders, and we have to make sure there's power to those grinders. And that grinder is powered up by just plugging into a regular 110 socket. All right, so we make sure it's plugged in. We move here. This is our on and off switch. Up is on, down is off. You want to make sure it's on. It's not rotating just yet because there's another step that we must take. After we turn it on, there's a pedal down at the bottom here, and if you place your feet on this pedal and push it down, that's when your bench grinder will start rotating. Here we have the actual tools that we're going to use and the PPE that's required to operate the bench grinders. First thing is your face shield. You want to make sure you have double eye protection at all times. Next, here you have your tungsten tote. You have your 2% seriated tungsten that you received from the school, your gloves, and a actual drill that I'm going to show you how to incorporate that in order to enhance your efficiency at the bench grinder. Now let's get into the different ways to actually hold your tungsten while you're sharpening it. One way is going to be to hold your tungsten in your hand and get it sharpened. The second way I'm going to show you is to actually use the tungsten tote that you were provided with in your equipment. And the third, more advanced, the safest way that you're going to approach sharpening your tungsten is going to be to use a drill. Okay, so I'm going to show you those ways, and we're going to just dive right into it. All right, so stepping up to the bench grinder, we all know that we have to have it powered on. We have to put the switch up, and we have to squeeze down on the pedal so that the blades will rotate. Diving right into how to actually hold your tungsten in your hand while you're sharpening it. So for all my right-handed guys out there, we're gonna always go right hand on the bottom side of your tungsten. And for my left-handed guys, just put everything that I'm saying in reverse, right? Just do the opposite. So if I say for my right-hand guys, put your right hand on the bottom, left hand on the top, then my left-handed guys, you'll do the opposite. So approaching the bench grinder itself, like I said, you're going to put your right hand on the bottom, your left hand is going to go about halfway through. I'm going to place my hand on the front side of this guard, and I'm going to press the tungsten up against the wheel, and this is why it's spinning. Right now we don't have it spinning because we're trying to get a good understanding on just how to hold the tungsten. So right hand back, left hand forward. We're gonna approach the grinding wheel while it's going, and we're gonna do 360-degree turns with our backhand, with the right hand, using the left hand to brace the tungsten off. You can also use that guard to rest your tungsten on. Use your left hand to support, your right hand to twist, right hand, left hand combination, and we're gonna try for 180 to 360-degree turns, either to the left or to the right. It do not matter. It does not matter, left or right, and we're gonna get that tungsten sharpened by hand. Another way to hold your tungsten while you're sharpening is going to be to use the tungsten tote. All right, the tungsten tote kind of operates something like this. You're going to get your tungsten, you have your tote here, you're going to place your tungsten inside of that tote, and how you're going to do that, you have to open the jaws of this tungsten tote. And the way you're going to open the jaws is you're going to turn your top cap to the right. It's going to open the jaws just a little bit. You're going to place your tungsten in. You're going to have about 3 fingers linked out and turn it to the left to tighten. The final way that I'm going to get into to show you how to sharpen your tungsten, how you're going to hold your tungsten, is going to be to use a drill. Your drill is going to work like this. So you have to loosen your drill and tighten your drill. There's ways to do that. The first way is to open the jaws and loosen the jaws of that drill is going to be to hit your button here, push it out to the right. You're going to hit the trigger, hold the rotating part of your nozzle, and it'll open up. You're going to place your tungsten in. Any side will do, but most of the time we'll put the tungsten in the colored side so that we'll know, or an inspector will know, or your boss would know what tungsten you're using. Put your tungsten in to the back, switch the switch, push it from right to left, hold hold the rotating part of that nozzle, trigger, slowly but surely, and then it'll tighten up. Done deal. As you approach the bench grinder, just gonna stand whatever distance you need to. Place your tungsten up against the wheel. Hit the trigger. So far, we've talked about the PPE that's required to sharpen your tungsten, face shield, gloves at a minimum. We've talked about the tools that we'll use to hold the tungsten tote, by hand, and a drill. Now we're going to talk about the finished product and what that finished product should look like. There's 3 typical or common degrees or angle degrees that you want your finished product to be. First tungsten here has a 15-degree angle finish. Second tungsten has a 30-degree angle finish. And this third here has a 60-degree angle finish. All 3 of these finishes are going to affect your weld in different ways. The 15-degree angle is going to spread your heat just a little bit more. Your 30-degree, which is pretty typical, it's pretty much what probably half of the guys in the industry would use. That second, which is the 30-degree, is going to concentrate your heat just a little bit more narrower than your 15-degree. But your 60-degree is going to concentrate that heat directly in the area that is pointed to, and that's when you want just a little bit more penetration, a little bit more fusion in that weld. Everything that we have done thus far on these videos are just the side dishes to the main course. You know what that main course is? That main course is to actually lay down a weld. So, first thing you'll have to know before you lay that weld down is how to connect your TIG torch and your stinger to the actual weld machine so that we can get this weld going. 2 pieces of equipment, main pieces of equipment that we're going to need to hook up to the machine is going to be our TIG torch that we talked about earlier. We got it all hooked up. We got the cup, we got the back cap, everything is good. And we're going to need our stinger, which you should be familiar with, right? Because you've already used your stinger. Now, I'm going to take my stinger and hook it up to the terminal that's inside of my boot. Normal, regular activities, that's the usual. Lock it in, put it to the side. Now, I'm going to take my TIG torch and I'm going to locate the power block that's in my boot. Power block is here. That power block should be connected to a hose that's connected to your flow meter that you're going to turn on here in a minute. So I'm going to take my male end of my TIG torch and put it in the female end of the power block. Tighten it down, turn it in. After I turn it in as far as it can go, I'm going to grab my crescent wrench to finish off the job. Crescent wrench, tighten it down, take it off so that I won't have any leaks while I'm making my weld. You may have seen your flow meter or other flow meters in different boots around the shop. So now we need to know exactly what that flow meter does, exactly what it's used for. With stick welding, There really isn't an outside shielding gas to shield your puddle from contaminants. But with TIG, it's pretty different. With TIG, we're going to introduce a gas, an inert shielding gas called argon. And that argon is going to flow through that flow meter at a certain rate once I set it, and out of your torch to actually cover your weld, shield that weld until that weld cools down to ensure that you're not getting any porosity in that weld. To start the flow of your gas, it's going to be a valve, an open and closed valve. You're going to have to put that valve in the open position. You're going to grab your TIG torch and release, turn that release valve to get your gas to flow from the flow meter through your torch, like so. Now, if you hear that gas, the gas is pretty loud, it's flowing out of there. I mean, that sounds almost as if that gas is turned all the way up, the valve is all the way open, and it's pretty excessive. And we do not need that much gas to flow out of the torch in order to cover the weld. So what I'm going to do, I'm going to set the gas flow. Not only just open the valve and allow it just to freely flow out of my torch, I'm going to set that gas flow, and how I'm going to set it is going to be my adjustment valve right here. So I open it, I'm open here on my shutoff, it's in the open position. I open my valve to release my argon, and now I'm going to go to the adjustment valve here to turn it down just a bit. So how do I know when to stop? So if I turn this all the way down, you'll notice that there's a float ball inside of this tube that's going to get to a certain level, and it's going to allow you to understand and know what amount of gas flow, which measured in CFHs, which is cubic feet per hour, how much gas flow is going to come out of your torch. So typical gas setting is going to be anywhere between 25 and 35. I'm going to run that right at about 30, which is on the high side of the parameters for what we want to do. And that'll be about it. We have our gas set, have it coming out of there. I'm going to close it here because it's already set on the flow meter until we are ready to weld. Stepping over to the machine, I'm going to examine the face of that machine and make sure that every button, every terminal is correct, in the correct position, so that I can run a TIG weld. First thing first, before I even turn it on, I'm going to check my polarity. Your polarity now has to be DCEN, which is DCE, direct current electrode negative. And in order to do that, I'm going to have to take my ground terminal out of the negative and place that terminal into the positive side. Next, I'm going to have to place the terminal that was in the positive side, I have to place in the negative side. So basically what I just done is switched the terminals. The green is normally my ground, is normally on the negative side when I run stick, so I just switched it over to the positive and switched the terminal that was in the positive to the negative, which brings us to direct current electrode negative. Next, I'm going to turn my machine on, power it up. If I'm going to be in DCEN, which is direct current electrode negative, I'm going to turn my switch to negative. I want my weld terminals on, moving up. I'm going to select a process, and that process is going to be GTAW amperage setting. Because we're going to run on flat plate, I'm going to turn it up just a little bit. I'm going to run on at 120. local or remote, we want it local. If I were to switch it here, that means I want a remote to connect to this machine and turn my amperage from that remote. So here I want it local. Last step in the setup, I'm gonna take my stinger, walk over to the power block, and connect my stinger to the power block in order to ground my torch. Ooh, we're getting close, we're getting close. Now that we have our machine set up, there's a couple more steps that we must take in order to prepare our plates and grab our filler metal, and we're gonna get going, man. So what we have here is some flat plates, my speed square, soapstone, a cutting disc, my grinder, and my filler metal. The filler metal that we're going to use today is going to be ER70S6. The ER stands for electrode rod. 70 is the strength of that rod. It's 70,000 pounds per square inch. The S stands for silica, and I'm going to maybe explain that a little bit more in the video. And the 6 is actually the scientific representation of the chemicals that's used to make up this rod. First thing you want to do before you do any type of welding, I'm talking about in any process, be it stick, TIG, MIG, or flux, is to clean your base material. Your base material has to be clean. It has to be bright and shiny, almost down to a nickel type shiny finish, okay? Because if you do not clean your mill scale, if you do not grind the rust and the contaminants off that plate, then that contamination will get into your weld, and it will cause your weld to not shoot maybe x-ray, or it'll cause your weld to be weaker. Let's say that weld is going to be weaker. So I'm going to get my plate, clamp it to the table. And any time that you're going to grind, you have to use your earplugs. All right, get your earplugs in, because we want to be safe, man. We want to be safe in everything that we do. That repeated exposure to that loud sound, it would actually cause you to possibly lose a small percentage of your hearing, and we don't want that. We want you to leave here the same way you came. Double eye protection, protect my eyes. I am a welder. If I don't have good vision, then how am I going to weld? Double eye protection while I'm grinding at all times. Wherever weld touches has to be bright and shiny. We want a nice, clean weld. The cleaner the weld, the stronger that weld will be. Now that I have my plates grounded down to bright, shiny metal, I'm going to move to the next stage. The next stage is going to be to mark this plate with a straight line so that I can weld over and ensure that my first weld is straight. I am going to unclamp here, grab my speed square, connect my speed square to my plate, grab my soapstone, run it along my plate. Switch over from my 1/4-inch grinding wheel to my cutting disc, and I'm going to grind along that line. Perfection. Now that you've finished grinding your first line, We're gonna put another line to run parallel with that same line. That next line is gonna go approximately a half an inch away from the first in order to kind of represent a border in which you're gonna weld in between. Speed square, chalk, guys, we are prepped up. We have our plates prepped up, ready to go, nice and shiny. I have my lines that I'm going to weld in between. The only thing that's left really is just striking an arc. But there's one question: how do I strike an arc? So there's two different ways to strike your arc with GTAW. One way is going to be scratch start. Another way is going to be lift arc. Let's talk about lift arc for a second. So with lift arc, what happens is you'll set your cup on whatever part that you're welding, and you're gonna tap your tungsten to the plate with the intentions of coming off. You're gonna tap it, and you're gonna come up about 1/8 of an inch, and your arc should be lit at that moment. So tap, arc should be lit. Next technique, or next way we're going to talk about is scratch start. With scratch start, you're going to take your TIG electrode, and let's go ahead and happen this electrode up just to make it a little bit more manageable while we're welding. A lot of times that filler metal gets a little bit heavy, so what I did was I took my pliers, put my filler metal to the back, pressed down, just a little bit of pressure. I went halfway through. I did not try to cut it all the way. Once I get a little groove and get it bent pretty much, I can put pressure and it'll pop right off. So, scratch start. Let's talk about that for a second. Scratch start, I'm gonna place my cup onto my plate, and I'm gonna give my tungsten just a little bit of distance from the tungsten to the plate, about the same width of the wire itself, and I'm going to basically scratch my plate and my tungsten at the same time, running it in between, which will strike my arc, and then I'll start welding. Just as there are two different techniques to striking your arc, there's two different techniques to moving along this plate and actually making that weld. All right, the two techniques are freehanding and walking the cup. Walking the cup is going to consist of a disciplined movement to move your tungsten from side to side in order to spread the metal from edge to edge. Your next technique is going to be freehanding. And with freehanding, it's not as it sounds, which is freehand as in I'm not touching anything and I'm just going side to side. What you're going to do with freehand, you're going to actually support your hand some sort of way. So what I'm going to do is grab my torch here on the handle. I'm going to poke out 3 fingers and bring my tungsten really close to my weld and support my movements from side to side, all while keeping the tungsten the same distance away the entire time, which is approximately a 1/16 to 1/8 of an inch. Walking the cup. Walking the cup is the technique that's going to get you the prettiest weld that you can possibly get. I'm talking pretty. The welds that you Google on the internet, when you Google TIG welding, you're going to see a lot of those guys walking that cup, making those extremely beautiful welds. So that's what we're going to talk about here for a second. While walking the cup, you're going to set your cup down on your plate. You're going to grab your torch, not too tight, keep it a little bit loose, and you're going to do a certain movement. Now, that movement is going to resemble a figure eight. It's going to resemble walking a barrel as if you were trying to move it from one place to another. How I like to explain it is I like to treat this circle like a square. Follow me. One corner here, one corner there, corner, corner. Much like a square, this circle has 4 corners. I'm going to utilize that philosophy of corners and walk this cup like I'm trying to move a heavy box, okay? So as I lay my cup onto my plate, I am going to rotate or roll my cup to my corner, and when I get to that corner, I'll stop and swing over. Roll my cup to the opposite corner, stop, swing over. Roll my cup to one corner, stop, swing over, roll, pivot, swing it over. Okay? Now I'm going to set my plate up so I can get in a good position where I can really show you how that works. Grab my hood, load up, get my plate in position, and that position is going to be getting my plate kind of off of my table so that I'll have a little freedom with my movement, and I'm not so restricted with hitting my torch on the tables or the plate. Now, one thing I haven't really spoke on is turning on my gas. That can be a major problem. Let me tell you something. Every time you make that weld, you have to turn that gas on, all right? Whenever you're gonna be out of the boot for an extended period of time, you wanna turn your gas off. You know, you wanna get into the mode of, okay, I'm gonna save my company that I'm working for money, because that saved money could mean a raise for you later. But while you're in the boot, man, you turn that gas on and you let it roll. All right, so I'm gonna turn our gas on. I can hear it, put it up to my ear, I can feel it. And we're gonna do it. That was walking the cup with a scratch start. I told you about 2 techniques, and now I have to show you another technique. So the next technique is going to be freehand, right? It's going to be freehand. So freehand doesn't actually mean that my hand is going to be free. It only means that I will not set my cup onto the plate, and I'm going to support my hand with my fingers as I make my weld. I'm going to do freehand, and I'm going to do lift arc this time. So with lift arc, I'm going to just touch the plate, just going to tap it, kind of peck it like a woodpecker, and come up, let my puddle develop, and I'm going to start my weld going from side to side, side to side, basically edge to edge, all the while having my filler metal sitting right in the middle, going right over, edge to edge, edge to edge. Yes, sir, get her done, because TIG welding is fun, no doubt about it. So we've laid down a bead, and I kind of like how it came out. It looked pretty good. I mean, we have one where we walk the cup, and we have that nice snakeskin overlay, right? And the other where we kind of freehand it, where we connect it to the walking, and you can see the difference. Freehanding is a little bit unsteady. You know, you'll go outside of the line just a little bit, but you can get this weld done either way, walking the cup or freehand. If you want that nice, pretty, beautiful weld, you're gonna have to work on walking that cup. Don't take the easy way out. Get on walking that cup. Some situations, you'll have to freehand, so you'll use that technique then. But if we want to put our best foot forward, we want to make the most wonderful impression on that employer or on the next guy that's watching us weld, we're gonna walk that cup. But there's two ways to get it done. So moving on, we also have to do what's called overlap. You all were introduced to overlapping your beads in 101. So that's going to be the same thing we're going to do here. Same rules apply. We're going to cover 50% of the previous bead with the current bead that we're going to lay down. Okay? That's the only way that we'll get a really, really strong weld. If we cover half the bead with your current bead, and half of that current bead should be on the plate. All right? Let's get to it. right, man, we covered a good bit of information just to get you guys started, man, with the basic fundamentals of TIG welding, right? We showed you guys how to put your torch together, showed you guys how to connect to your machine and make that weld. So don't forget, man, to like, subscribe, and share these videos. And if there's any videos that you want to see us do, put it in the comments. Let us know. I'm Derrick Jack, Senior Instructor at Tulsa Welding School, signing off.